Hello and welcome to this session. In this session I'm going to talk about plural, genders and numbers. So in general we're going to create a composite format strings, and those are the strings that almost all applications use, and they are created by combining a constant string with variables, and those variables are not known at compile time but on the runtime. So it's basically those plain old format strings that we use. And this session is mostly for those who are planning to localize the applications. But if you have no intent to localize your application, you can still use these classes to make the user experience better, because these APIs I'm going to show here are going to help you to produce better messages and better user experience. Okay, my name is Jaakko Salmenius. I'm a localization software engineer. I mostly use Delphi, but recently I've been using more and more C# and TypeScript. And I've been developing localization and internationalization tools over 20 years, mostly in Delphi, and I've been using Delphi since Delphi 1. I'm a big fan of Delphi, of course. And today's agenda is all about composite format strings. And any application larger than Hello World probably use these composite format strings. And whenever we going to generate something that is constant and variables, we might run into troubles in the grammatical point of view. For example, we say I have one car, but if I have two, then I say I have two cars. So each language has different rules to handle singular and plurals, and actually there are languages that don't even use plurals, and there are lots of languages that use more than just a singular plural. For example, most Slavic languages use 3, and Arabic use 6 different forms. In the same case with grammatical genders, most languages has concept of male and female, and some languages even have a neutral. And the third topic I'm going to show you today is abbreviated numbers. Nowadays it's quite often that we have to show some big numbers, like for example if you have a YouTube video and there's a 2,755 likes, it's a little bit unpractical to show it like that. It's better to show just 14M, which means 14 millions. And unfortunately all languages are going to abbreviate numbers in a little bit different way. And because everything I show here is pretty much local and language depend, there must be rules to do the pluralization and genders and number abbreviations. But lucky for us, there are common rules called CLDR. It's a Unicode Consortium project that collects the rules in each languages. So the API I'm going to show you is a 100% native Delphi API. It's open source, it's available from GitHub. The logic is written in Delphi, but the rules come from CLDR. They are converted to Delphi code that are embedded into API. And let's start with this grammatical numbers. In most languages we have a concept of plural. Like here you can see I have one car, I have two cars. But whenever we have to generate a message like that, we don't know how many cars there are in the development time. Instead we're going to put a placeholder. That person T represented a placeholder, and and if we just have one pattern, I have and placeholder, so what are we going to do here? It's a little bit challenge. I'm going to show you later how to do that. And some languages, like East Asian languages, don't use plural at all. And as I told, some other languages use 3, 4, 5 or even 6 different forms. And even two different languages, like for example English and French, they both have a plural and they both have a singular, but the rules when to use a singular and when to use plural are a little bit different. Okay, that's the short introductions, and let's go to Delphi now. I have created here a small sample. I put the font a little bit bigger that you can see better. And let's start doing something. Let's write a procedure like plural, and it's going to have 2 parameters, label and count. Okay, like this, and then we're going to call it plural label 1 and 2. And then we're going to generate some kind of message that tells you about 2 something. Let's put I have. So this is the beginning, and then we're going to inject the number here. So let's convert that to string. And then we're going to put the end cars. So we're going to produce something that I have 2 cars. We get I have 2 cars. Okay, it looks good, but we have some issues here. First of all, as you can see, we have split our string, the constant part, into 2 different parts. I have and cars. They belong together, but now we have 2 different strings, and if we ever want to localize this, it's going to be very difficult, even impossible if we have to move this somewhere else. So it's always better not to use a string plus string plus string, but instead to make a composite string pattern like this, and use format. Okay, we're going to replace that, and then put the parameter. So what's going to happen here, that we have a pattern here. I have the cars, and then inside the pattern there is a placeholder. This represents the placeholder, and on runtime this format function is going to inject this count, that it knows that it's a number inside here, and produce the string. So now when we run this, we should get exactly the same I have 2 cars, but this implementation is much better. Okay, let's go here and add a couple of 2 labels. I'll put here 2 other labels, and then I'm going to inject different numbers here. First the 0, then 1, and then 2. And we now run this. We get I have 2 cars, which is correct, but then we get I have 1 cars, which is grammatically incorrect, and then we get I have 2 cars, which is correct. So how can we going to fix this? Windows doesn't have, and Delphi doesn't have any native API to handle plurals. So that's why I've seen quite often that developer write something like this. So we're going to put actually if here, and if a count is 1, then we're going to put I have car, and then in any other cases we put like this. So we have two patterns. We have a plural pattern and we have a singular pattern here. Now when we run this, we get the grammatically correct solution. So in this case the developer might think, wow, I did that. My application works greatly. But we still have a major problem here. And the problem is that we have now hard-coded the English rule here. So no matter in what language we run this always follows the English rules, that we're going to use a singular whenever the count is 1, and on all other cases we're going to use a plural. So how are we going to handle this? And here's where's my Delphi library comes in. It's actually using the language-specific pluralization rules to make it possible to use different patterns and any number of patterns. And let's go here first to see this CLDR. This is a Unicode consortium project that collects all kind of language and local depend data into database, and then they expose that database as XML files. So if we go here to see this XML files, we can see that let's open English here. Over here we open the English. You can see it's quite big, the file. It's almost a half megabyte, and this is a huge XML file. It contains the language names in English and country names in English and weekdays and months and everything that is related to languages and locals. We can find them. Weekdays over. They are here, and then, for example, if we put lots of zeros here, we can see how the numbers are written down as a text. So we say thousands and millions, and then we can see the abbreviated versions. So whenever somebody writes an operating system like Microsoft, they probably took lots of data from here, but there are lots of data that they didn't take it. So for example, abbreviated numbers and those pluralization rules, they do not exist in Windows, and in that case they don't even exist in Delphi runtime library. But here they are, and how we can use them. Let's go to see the plurals rules here. They are in supplemental and plurals. So if we run this, we can see that this is the simplest one. You can see that this group of languages, you can see the languages from here. For example, there is a Japanese and there are Chinese, and they don't have any plural. They only have one form. You always use other. Other means usually plural. And then there is a group that has used singular and plural. But the rules are different. Like if we look this one, here it goes such way that a singular is always when we have a integer 0 or 1, and everything else is plural. And then we go a little bit down here where English is. here we can see that we have a German, we have a English, we have Finnish here, and here the rules are so that singular is when there is integer 1. If there is a decimal 1.0, it's not singular, it's plural, and everything else is plural, and so on. There are lots of different kind of rules, and more further we go here, the rules get more complex. Like Slovenian has 4 different versions, and then we go all the way down to Arabic. We can see that there are 6 different rules, and Welsh has also 6 different rules. So the basic idea of my library is that I wrote a tool that is going to read these XML files, and it generates a Delphi code. And that Delphi code is used together with the actual library Delphi code, and then we get the results. As a result, the library is 100% Delphi. There is no requirement for these XML files, and you don't need any DLLs. Let's go to C. You can go to GitHub. It's github.com/jaska45/i18n, and here's a short description of the library, and the library section contains the Delphi implementation, JavaScript implementation, .NET implementation, and TypeScript implementation. And later on I will add a Java and probably other languages. And this is all open source, you're free to use it. And there is an extensive amount of samples here for both VCL and FireMonkey. So let's go back to this sample and let's start using the library. So we're going to include NT pattern. We will go to see what's here. Just a plain Delphi code, and actually that use another additional file, NT plural data. And this is a file that has been generated from CLTR using the application, so you shouldn't edit this. This contains the rules. So everything we saw in this XML files is now in a Delphi code here. So it's easy to use. And then it first implements the rules, and then it registers them. So basically this is ready for all languages, so you don't have to write your own rules. If you don't want all the languages, all the commonly used languages are here, ready to use. The usage is pretty simple. We take it use pretty much like a format, but instead of format we're going to use T multi-pattern format. And as the name indicates, this is a multi-pattern. We're going to pass multiple patterns here, and our first pattern will be for singular. So these codes, there are 6 different codes: 0, 1, 2, few, many, and other. They are for different groups, and all languages they use at least one of those groups. Some languages, as I mentioned, use all those groups, but our original language here is English, so English only use one and other, singular and plural. So we're going to put these like this. So we have 2 patterns here, singular pattern here and plural pattern here. That's all we have to do. So now when we run this it works exactly like it used to be, but now it's ready for localization. And then I'm using a new localization tool that has not been released yet, and it doesn't even have a name. But the nice thing is that it has a wonderful support for plurals and genders. So let's go here in our sample. We created. Going to just select the XC here, and don't want to localize versions. Let's scan the source code to get those strings, and let's have Finnish here, let's have Japanese, and let's have Polish. Okay. So I put the font a little bit bigger there, you can see it better. Let's save this. You can see that there is one form here and our strings here. Now here you can see that this multi-pattern string is now nicely showed here. That it shows that there is a singular pattern and there is a plural pattern. If I go here and start typing, I can just type the Finnish translation. Minulla on yksi auto. And then auto. The application knows that Finnish also uses singular and plural, and it shows them. And then we're going to add a Finnish here. Then we go to Japanese. Start typing, and only one pattern appears because the application knows that Japanese doesn't use plural. So we're going to just type kuruma moteimasu, and then let's put a Japanese here, and then finally let's use Polish. And now what happens when we start writing, there will be 3 different forms. I don't know Polish, so I just write here like in English, car, and you can see that there is a singular paucal and many plural. So this paucal is something that does not exist in English. It's used whenever it's 2 or 4. So there are 3 different forms in Polish. Okay, then we save this and we build. So it created now Finnish, Japanese and Polish executable. And if we go here and run the Finnish, we're going to see exactly the right result. And Japanese, it works correctly, and then finally Polish, it works correctly. So let's go next to see what's inside there. I'm now using a tool called Resource Turner. It's actually quite handy tool to see what's inside the executable. So if I drag the English XC file here and go to C, we can see that here is our multi-pattern string. One singular and plural. Let's start another one. And let's grab the Finnish one. And here's the same thing now. We have a singular, but it's in Finnish. And then we have a plural, but that's in Finnish. These codes are the same because this must be one and another. But then if we go here to Japanese, things are a little bit different. Now we only have a one pattern. And just ignore this question mark. This application is old. It cannot show the Japanese text correctly. But the main idea is that we only have one pattern, the plural pattern here. And then if we go to Polish, we have all three. We have a singular, and we have a Paucal, and we have a plural, many plural here. So this is how this multi-pattern works, that we're going to put the multiple patterns in one single string, and then we can use the plain old resource string to hold them. We don't need a dedicated resource structure for plural. Some operating system, for example Android, has a dedicated version, but because Windows doesn't have, we have to use a plain old resource string. Okay. And let's go back to this application and let's comment out these plurals here, and let's create another one called gender. And now our parameter is going to be name. It's a string. And we're going to create a different kind of message. Caption, format, will bring his keys. And so in this procedure we're going to pass a name, and that name will be the person who will bring his or her keys, and then I'm going to use it here, and let's put here John, and let's run this. John will bring his keys, which is correct. But then if we pass a Jill and run this, we're going to get the we need to put this second here. Okay. John will bring his keys, which is correct. Jill will bring his keys, which is not correct. It should be her. So how we fix that? Quite often you can see something like this. Okay, this probably works, but it's a little bit hard to read, and you cannot do that with all languages. So just like the plurals, we can now use multi-patterns. So we're going to take this multi-pattern here, and we're going to add an extra parameter here, gender. That's a type of gender, and if we go to see, there are three different, it's enumeration: male, female, and neutral. We're going to pass that with our with our name. So here I'm going to put the GE male, and here I'm going to put the GE female, and then I'm going to add a male pattern here and a female pattern here. We can remove her here and his here. So we have two patterns, one pattern for male, another for female. And now when we run this, okay, I forgot to put this here. Okay, let's run again. Okay, John will bring his keys and Jill will bring her keys. And we can always put the fallback other. The other can mean something else or neutral. So we can put something like this, will bring the skis, and then we can put here, for example, let's put this to neutral. Amazon will bring the skis. So now we have a male, female, and then something else, and we have a different pattern for all of them. Okay, so these are the genders. Okay. And the next thing I'm going to show you are the numbers. So let's again add something else here. Number, and let's put a 1000 here, and let's put 2 million here, and let's put 140 million here. Did I get them right? Yeah. And then we have to implement this. So we're going to pass the number, and then our purpose is to show it like how many likes. So let's put something like format, and then the number likes, like this, likes, and then we pass the number here. Okay, and then when we run this, we're going to get the amount of likes. As you can see, when the number gets a little bigger, it's getting very difficult to read that. How many zeros? What's the magnitude of the number? So of course we can use the proper way to convert them to number and using the runtime library. But in many cases it's better actually round and abbreviate them. And in order to use that, this API contains the number API. We go to number. This is the library code. It's very simple. We pretty much have a abbreviated number class, and there's a couple of formats here. Another one, the data, is again extracted from CLDR, and this is actually quite huge. If you want to a little bit optimize, you don't want to add all languages here, because now there are the abbreviation rules for every single language here, and the file is quite big. But if you don't mind about size of your application, just leave it like this and let them all be here. So we can easily use it here. Abbreviated number and format short. Okay. So now if I run this, oops, because this is going to generate a string, I have to put S here. Okay. And now I have 1k likes, I have 20 meg likes, and 1.4 billion likes. Much easier to read. And remember one thing, that English go, and most Western languages go by thousands. We say, or 3 digits. We have a 3 digits, 1000, and 6 digits is million, and 90s is billion, and so on. But there are languages that doesn't work like that. So let's temporarily turn this to Japanese. So now the engine believes that this is Japanese, and if we run this, we're going to get a different. Now you can we don't see those 20 meg and 1.4 billion anymore. We're going to see 2,000 10,000s, and then we're going to get the 1,400 millions. So they are called, the first one here is man, and this is oku. And then if we go here and turn the Finnish on and then run the same thing, we're going to get a little bit different. In Finland we use those K's, M's and B's. Actually nowadays they are getting more popular, but it's more like a I don't know, new trend. But these are the correct abbreviations. So the 1,000 is T dot, and the million is MILJ dot, and the billion is MRD dot. So this is how you abbreviate numbers. And then I'm going to talk a little bit more about the plurals. Let's comment this out and turn the plurals on again. And let's put this closer so it's easier to see. So the English requires you to have a singular and plural, but you are not limited to that. You can add additional variations here if you want. Let's say that we want to handle zeros in a little bit different way, because when we run this, we get a. Let's put this back to English and run again. When we run this, I have 0 cars. It's correct, but it sounds a little bit odd. So let's make a special case for 0. So we can just use a equals 0. I have no cars, like this. So now when we run this, we're going to get I have no cars, I have 1 car, and I have 2 cars. And we can play even more with this. We can add here equals 10. I have a dozen cars, like this. And let's add here another one. Let's add 4, and then let's put here, and let's add one more 5, and then let's put 20 here. Then we have to go here and make some copies. Add 2 extra labels here. Okay. Now when I run this, I'm going to get I have no cars, I have 1 car, 2 cars, I have a dozen cars, and I have 20 cars. And there are more things. I don't have to use equal. I can put it roughly. Let's put it like this, and then it's abbreviation. So 11 goes here. There is a global variable where you can specify the range, and then I can have a more than 50. I must be a car dealer, like this. So if we now run this, we're going to I put it into sorry about that. It's a little bit difficult to edit this. So this is pattern for 1, this is pattern for 0, this is pattern for 1, this is pattern for dozen, and then if we go here, this is a pattern when we have more than 15, and everything else I have just cars. So when I run this, now I get what I want. So there are lots of different options here. You can go to the GitHub and get the library and read the documentation and play with the samples, and then you're going to see how it works. Okay, this was my session, and now I'm open to any QA you might have.